The universe is a vast, ever-changing expanse, filled with phenomena that both awe and terrify us. Among the most captivating of these cosmic events is the potential supernova of Betelgeuse, a red supergiant star located in the constellation Orion. Betelgeuse has long been a subject of fascination for astronomers and stargazers alike, not only because of its prominent position in the night sky but also because of its sheer size and luminosity. Recently, rumors and speculation have swirled around the possibility that Betelgeuse has exploded, or is on the verge of doing so. This has prompted renowned astrophysicist Neil deGrasse Tyson to weigh in on what such an event would mean for us on Earth and what we might expect in the aftermath. In this article, we will delve into the science behind Betelgeuse, the nature of supernovae, and the potential implications of such an event. We will explore the history of Betelgeuse, its current state, and the signs that astronomers are watching for to predict its eventual fate. We will also examine the warnings and insights provided by Neil deGrasse Tyson, one of the most prominent voices in astrophysics today, and consider what the future might hold if Betelgeuse were to go supernova. The star Betelgeuse, a cosmic giant. Betelgeuse, also known as Alpha Orionis, is one of the brightest stars in the night sky and is easily recognizable as the right shoulder of the constellation Orion. It is a red supergiant, a type of star that is much larger and more massive than our Sun. In fact, Betelgeuse is so large that if it were placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. This immense size is a result of the star's advanced stage of evolution. Betelgeuse is estimated to be between 8.5 and 10 million years old, which is relatively young in cosmic terms. However, because of its massive size, it has burned through its nuclear fuel at a much faster rate than smaller stars like our Sun. As a result, Betelgeuse is now in the final stages of its life, and astronomers believe that it is on the verge of undergoing a supernova explosion. The life cycle of a star, from birth to supernova. To understand the significance of Betelgeuse's potential supernova, it is important to first understand the life cycle of a star. Stars are born from vast clouds of gas and dust known as nebulae. Over time, gravity causes these clouds to collapse, forming a protostar. As the protostar continues to contract, its core temperature rises until it reaches the point where nuclear fusion can begin. This is the process by which hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the form of light and heat. For most of its life, a star will remain in a stable phase known as the main sequence, during which it fuses hydrogen into helium in its core. The length of time a star spends in this phase depends on its mass. Smaller stars, like our Sun, can remain on the main sequence for billions of years, while more massive stars, like Betelgeuse, burn through their fuel much more quickly. Once a star exhausts the hydrogen in its core, it begins to fuse helium into heavier elements, such as carbon and oxygen. This process continues, with the star fusing progressively heavier elements in its core, until it reaches iron. At this point, fusion can no longer occur, as the process of fusing iron requires more energy than it releases. Without the outward pressure generated by fusion to counteract the force of gravity, the star's core collapses, leading to a supernova explosion. What is a supernova? A supernova is one of the most energetic events in the universe, releasing an immense amount of energy in a short period of time. There are two main types of supernovae, Type 1 and Type 2. Type 1 supernovae occur in binary star systems, where a white dwarf star accretes material from a companion star until it reaches a critical mass and undergoes a thermonuclear explosion. Type 2 supernovae, on the other hand, occur when a massive star, like Betelgeuse, exhausts its nuclear fuel and its core collapses. In the case of a Type 2 supernova, the core collapse triggers a shock wave that propagates outward through the star's outer layers, causing them to explode. This explosion releases a tremendous amount of energy, outshining entire galaxies for a brief period of time. The remnants of the star's core may collapse further to form a neutron star or, if the star is sufficiently massive, a black hole. Betelgeuse's recent behavior, signs of an impending supernova? In late 2019 and early 2020, Betelgeuse began to exhibit unusual behavior that caught the attention of astronomers around the world. The star, which is normally one of the brightest in the night sky, began to dim significantly. This dimming, known as the Great Dimming, led to widespread speculation that Betelgeuse might be on the verge of going supernova. However, as astronomers continued to observe the star, they determined that the dimming was likely due to a combination of factors, including the ejection of a large amount of dust and gas from the star's surface, which temporarily obscured its light. While this explanation provided some reassurance that a supernova was not imminent, it also highlighted the complex and dynamic nature of Betelgeuse's behavior. Despite the Great Dimming, Betelgeuse remains a prime candidate for a future supernova. Astronomers estimate that the star could go supernova at any time within the next 100,000 years, which is a relatively short timescale in cosmic terms. When it does, the event will be one of the most spectacular astronomical events in human history. Neil deGrasse Tyson's warnings: what to expect when Betelgeuse explodes. Neil deGrasse Tyson, the renowned astrophysicist and science communicator, has been vocal about the potential consequences of Betelgeuse's supernova. In his characteristic style, Tyson has both educated and cautioned the public about what to expect when the star finally explodes. One of the most immediate effects of Betelgeuse's supernova would be the incredible brightness of the explosion. Tyson has noted that the supernova would be so bright that it would be visible during the day, and could even cast shadows at night. The explosion would outshine the moon and become the brightest object in the night sky, second only to the sun. This celestial spectacle would be visible to the naked eye for several weeks, and could be observed with telescopes for months or even years afterward. However, Tyson has also cautioned that the supernova would not be without its risks. While Betelgeuse is located approximately 642 light-years from Earth, which is considered a safe distance, there is still a possibility that the explosion could have some impact on our planet. The primary concern is the release of high-energy radiation, such as gamma rays, which could potentially affect Earth's atmosphere. Gamma rays are a form of electromagnetic radiation with extremely high energy and short wavelengths. When a star goes supernova, it can release a burst of gamma rays, known as a gamma-ray burst, GRB. If a GRB were to be directed towards Earth, it could have significant effects on our planet's atmosphere, potentially depleting the ozone layer and increasing the amount of harmful ultraviolet radiation reaching the surface. However, Tyson has reassured the public that the likelihood of a GRB from Betelgeuse affecting Earth is extremely low. The star's orientation relative to our planet makes it unlikely that any gamma rays released during the supernova would be directed towards us. Additionally, the distance between Betelgeuse and Earth provides a significant buffer, reducing the potential impact of the explosion. While the immediate effects of Betelgeuse's supernova would be spectacular, the long-term implications could be even more profound. The explosion would provide astronomers with an unprecedented opportunity to study the life cycle of massive stars and the processes that occur during a supernova. One of the most exciting aspects of Betelgeuse's supernova would be the formation of a new nebula. When a star explodes, it ejects its outer layers into space, creating an expanding shell of gas and dust known as a supernova remnant. Over time, this remnant can give rise to new stars and planetary systems, as the material from the explosion is recycled into the interstellar medium. In the case of Betelgeuse, the supernova remnant would be a rich source of heavy elements, such as iron, gold, and uranium, which are formed during the explosion. These elements are essential for the formation of planets and the development of life, and their presence in the supernova remnant would provide valuable insights into the chemical evolution of the universe. Additionally, the supernova would provide astronomers with a unique opportunity to study the formation of neutron stars and black holes. If Betelgeuse's core collapses to form a neutron star, it would be one of the closest and most well-studied examples of such an object. If, on the other hand, the core collapses to form a black hole, it would provide valuable data on the processes that lead to the formation of these enigmatic objects. The cultural and historical significance of Betelgeuse's supernova. Beyond its scientific implications, Betelgeuse's supernova would also have a profound cultural and historical impact. Throughout human history, celestial events have played a significant role in shaping our understanding of the universe and our place within it. The appearance of a new star in the night sky, particularly one as bright as Betelgeuse's supernova, would undoubtedly capture the imagination of people around the world. In many cultures, the appearance of a new star has been seen as an omen or a sign of significant change. For example, the supernova that created the Crab Nebula in 1054 was recorded by Chinese astronomers and may have been interpreted as a sign of impending disaster. Similarly, the appearance of a new star in the constellation Cassiopeia in 1572, known as Tycho supernova, was seen as a challenge to the prevailing Aristotelian view of the heavens as unchanging and perfect. In the modern era, Betelgeuse's supernova would likely be seen as a reminder of the dynamic and ever-changing nature of the universe. It would also serve as a testament to the power of science and technology to help us understand and appreciate the cosmos. The event would be studied by astronomers around the world, and the data collected would contribute to our understanding of the life cycle of stars and the processes that shape the universe. Conclusion: the cosmic dance of life and death. The potential supernova of Betelgeuse is a reminder of the delicate balance between life and death in the universe. Stars, like all things, have a finite lifespan, and their deaths are often as spectacular as their births. Betelgeuse, a star that has shone brightly in our night sky for millions of years, is now nearing the end of its life, and its eventual supernova will be a fitting end to its cosmic journey. While the explosion of Betelgeuse would be a momentous event, it is also a reminder of the resilience and adaptability of life. The heavy elements formed in the crucible of a supernova are the building blocks of planets, and ultimately, of life itself. In this sense, the death of a star like Betelgeuse is not an end, but a new beginning, as the material from the explosion is recycled into the cosmos, giving rise to new stars, new planets, and perhaps, new life. As we await the eventual supernova of Betelgeuse, we are reminded of the beauty and complexity of the universe, and of our own small place within it. The explosion of Betelgeuse will be a moment of both awe and reflection, a chance to witness the power and majesty of the cosmos, and to contemplate the mysteries that still lie beyond our understanding. Whether it happens tomorrow or 100,000 years from now, the supernova of Betelgeuse will be a cosmic event for the ages, one that will be remembered and studied for generations to come.